In this video, we're going to go through pages 62 and 63, which is right triangle trigonometry, introducing you to the tangent function. And so right triangle trig is used to find a missing side or a missing angle in a right triangle when I know one side and an angle, or two sides. So when I know one side and an angle, I can find a missing side. And when I know two sides, I can find a missing angle. And so a trig ratio is a ratio of the lengths of two sides of a right triangle. What we're going to start with here is just a little bit of vocab and some preparation for how we set up a problem when we're going to use trigonometry. I'm just writing on the left because these are the same page on either side, so whichever one you're writing on, that's fine too. So in this diagram, I want you to notice this symbol here. It's kind of like a 0 with a horizontal line, so very different from like empty set, right? That means no solution. It's not the same symbol, so it's an O with a horizontal line. This is the Greek letter theta. So you should be familiar with some Greek letters from other, mostly science classes, like alpha, beta, gamma, all that stuff, right? It's the Greek alphabet. The Greek letter theta is most commonly used to label an angle. So that Greek letter theta is used for that in math. And so theta is the important part of the triangle. So when I'm given a triangle, a right triangle, I should either know one angle or want to know one angle. And so when we're starting with a right triangle, we want to label it in a particular way. So we know that a right triangle has two legs and a hypotenuse. So if I'm looking at the hypotenuse, that's the side that's across from the right angle, the longest side. So the hypotenuse of this triangle is this side. What's going to change is that I'm going to name the legs in a specific fashion. It's related to theta. So a side that is opposite theta is across from theta in the same way that the hypotenuse is opposite the right angle. So I can think about drawing a line from the right angle to the side. I can do the same thing with theta. So if I draw a line from theta to the side across from it, that's this side. So this is the opposite side from theta. And the location of theta determines where opposite is because it's literally in relation to theta. The hypotenuse is the only side that's always in the same spot with every right triangle. It's always across from the right angle. And then the adjacent side is the side that is next to theta. And so we only have one side left over. So notice that theta is here, the one that's touching it, that's not the hypotenuse. We call that the adjacent side. And again, adjacent just means next to theta. So opposite is across, adjacent is next to. So being able to label a triangle in this manner in relation to the angle that we're concerned with is the first step in being able to use a trig ratio to solve for a missing side or to solve for a missing angle. So in the front of page 63, we have some information. So there's this word in a box. So it says SOHCAHTOA. And so this says SOHCAHTOA. And this is just a mnemonic device to help you identify a trig ratio. Today we're going to talk about tangent. So we're going to think about TOA to create our trig ratio. So if I'm given a right triangle and I want to do any of the trig ratios, my first step is to label my sides as opposite, adjacent, and hypotenuse. So we always start with the hypotenuse because it's the one across, I don't know why I keep spelling it with an E. It's the one across from the right angle. And then we want to label the opposite side, the one that's opposite or across from theta, the same way that the hypotenuse was opposite the right angle. And finally, this other side that's touching theta, so hypotenuse and adjacent create the angle for theta. So SOHCAHTOA tells us how to write each of the 3 different trig functions we'll learn. The one that we're talking about today is tangent. These are always simplified on your calculator, so you might recall that looking at your calculator, you have a button that says maybe tan on it. So that refers to the tangent function. So if I want to find the tangent of theta, I'm going to write tan theta. That is equal to O over A. So T tells us to think about tangent of theta. O over A tells us that that is equal to the opposite side over the adjacent side. So when I have that word SOHCAHTOA, it's helping me remember 3 trig functions. Right now we only know this first one, tangent. So if I want to find the tangent of an angle, I have to take the side opposite the angle and divide that by the side adjacent to the angle. And those values will be equivalent. So what happens here is we're going to kind of practice with labeling a triangle. And so what's going to change is that there's no theta in this triangle. It's referring to the vertices. So sometimes that will happen. So if I'm looking at this triangle, the first thing that I want to identify is the hypotenuse. I'm just going to use O, A, and H for this point. Actually, I'm going to shorten them. So for the hypotenuse, it's across from the right angle. So I'm just going to use the first 3 letters. So the hypotenuse of this triangle is the side that says 13. The hypotenuse has nothing to do with the location of theta. And so the hypotenuse is 13 for no matter what, for every triangle, or for this triangle. And so this A is telling me the location of theta. So that means that if theta is here, right, if I'm thinking about theta as being in this spot, that would mean that 12 is opposite of A. And I'm writing the A opposite of A there because I'm also going to have to find tangent of B. And so if 12 is the side that's opposite A, the other side must be adjacent to A. So that means that this side 5 is adjacent to side A. So if I'm creating the tangent ratio, I'm going to put O over A. So the side that's opposite of A is 12. And the side that's adjacent to A is 5. So tangent of A is 12/5. Okay, so in this next problem too, they're now saying that theta's at B. So if I think about theta being at B, the side opposite B then changes. It's the 5. And so opposite of B is the side that's 5. So if tangent is opposite over adjacent, that means this one's going to have a 5 over the side that's adjacent to B is 12, right? This side 12 is right next to B. So notice that when I switch the angle in the right triangle, that switches where adjacent is and where opposite is, because that's all related to the location of the angle. So that switch only happens when I'm asked about the same triangle and 2 different angles within it. So we'll see this again later when we start to learn the other trig ratios. So on the inside, we're going to be looking at some different things to do with tangent. So first, we're just looking at how do I use my calculator to find the value of tangents of some angles. And so what I'm going to show you with is Desmos. So all that I did right now is search Desmos in Google so I could tell you which one you should be using. So for this, we just need the scientific calculator. So I'm going to click on scientific. And so that will load in the Desmos scientific calculator. If you have your own calculator and you know how to work it, you should be using that. You remember we wanted scientific calculators because they have these sine, cosine, tangent buttons. and we're going to use those to go through here. So this question is asking us to do tangent of 23 degrees. So it's talking about making sure calculator is in degree mode. So notice here I have the slider where it's saying radian or degree. And so you want to check if there's an R or a D, or it says rad or deg, and make sure that your calculator is in that degree mode. If you have a Casio, I believe it's under like mode. It's somewhere in there. You can just kind of play around with it, or maybe search on the internet how to change to degree mode, and your calculator model would be a good strategy to figure out how you make sure that yours is actually in degree mode. So for this, I'm going to type in tangent of 23, and notice that shows me my answer on the side. This doesn't tell me how many decimals to go by. With an angle, I'll typically go with 4 decimal places, because notice this is 0 point something. So this is a really small number. So since I have 0.4244, I'm going to cut there. So because I have a 7 after the 4, that means I'm going to make this 0.4245. Okay, so I'm going to go back over here. 0.4245 is tangent of 23. If you're using your iPhone to do this, you actually have to work backwards. So you would have to type in the 23 and then hit tangent. I'll show you with this calculator what I mean, because the one that's on this computer works in that same way. So give it a second. So again, it shows me that I'm in degree mode. If I click it, it tells me radians. So oh yeah, there's also that GRAD. I don't know what that angle is. So notice that I have to work backwards with this one. So I'm going to hit 23. Oops. I'm going to type 23, maybe. And then when I go up here, this has it under a different menu. I'm going to hit tan. And that's how I get that same answer, 0.4245. So again, if you're using your iPhone, it works like that, where you have to type the number first, then tangent. If you're using a calculator with a display, it usually works that way. Okay, so next one, we're going to be doing tangent of 57. So if I type tangent of 57, whoops, I did tangent twice, sorry. That gives us 1.5398, and then we have a 6 after that. So that means that we want to round up. So this one is 1.5399. Next, we're going to do tangent of 77. So if I do that, I get 4.3314. And then I've got a 7 after that 4, so that means I'm going to do 4.3315. And finally, we have tangent of 90 degrees. So if I do tangent of 90, it gives me undefined. So 90 degrees does not have a tangent. Value. Okay, so that's just using your calculator to calculate values for tangent. Again, if I'm asked to do that, I'm always going to do 4 decimal places unless it tells me something different. So I'm not just doing 1 decimal place. These are very small numbers, so you need to be as precise as possible. For the next set of 2 problems, we're going to be finding the side that's missing. So they're asking us to solve for x in both of these problems. What we want to do again to start is to just label our diagram with hypotenuse, opposite, and adjacent. So if I look at my right triangle, the right angle is here. So my hypotenuse is this side. I'm just going to write h for this one. And then the side opposite of the angle they give me is 75 degrees. Opposite that is x. And then the side adjacent to 75 then is 18. So remember that if we're looking at TOA, right, so we're using T equals O over A, that means that tangent of theta is equal to opposite over adjacent, we're going to plug in what we know. So in the triangle, we know that theta is 75 degrees. So we're going to do tangent of 75 degrees is equal to, the opposite side is our x, that's what we're solving for, over the adjacent side is 18. So when we're using this, we have a ratio. So since one side is a ratio, what we want to do is to make the other side a ratio too. So I'm always going to put that trig function over 1 and then cross multiply to solve. So if I cross multiply, I'm going to multiply 1 times x. So that's just going to give me x. And I'm going to set that equal to 18 times tangent of 75. So notice that x is already solved for itself, so I just need to calculate 18 times tangent of 75. So if I do this, I've got 18 times tangent of 75, and that gives me 67.17. So when I'm solving for a side, it's okay for me to do 1 decimal place. So if I have 67.1, I'm going to round that up to 67.2 because it follows with a 7. So that means that x is about 67.2. And again, I'm using the estimation equal sign so that, because I rounded on the calculator, right? That's not the exact answer. Okay, so let's look at one more. And so I always want to start any of these problems where I'm working with trig functions, labeling hypotenuse, and then labeling opposite and adjacent. So my angle here is 39 degrees. So that means that the side opposite that is the side that's labeled as 49. And then the final side, the one adjacent to that, is the side that's labeled x. So we're still using that same equation. Tangent of theta is equal to opposite over adjacent. So in this case, theta is 39 degrees. So tangent of 39 degrees is equal to, this time 49 over x. And so notice that what's different here is that our x is in the denominator as opposed to the numerator. So the process for solving is going to look a little bit different after the first step, because I still have a non-fraction equal to a fraction. So I want to put this over 1. On the last one, I started with the 1 and cross multiply that way because of x. I always want to start with wherever x is. So since x is in this one, I'm going to cross multiply this way first. Technically, it's okay if I were to always go left to right, but I'm going to do it so that I can always have x on the left side. So x times tangent of 39, I can't actually multiply anything. I'm always going to put the tangent piece last. So when I multiplied it by 18 in the previous problem, notice I put the 18 first. Whenever I multiply a trig function, that's always going to be the case. It's either number or variable times the trig function. Then I have to multiply 1 times 49, which is super easy. So that's just 49. And so we have x times tangent of 39 degrees is equal to 49. In order to solve for x, then what we have to do is get rid of the 39. Since this is multiplying, we're going to divide both sides by tangent of 39 degrees. So x is equal to 49 divided by tangent of 39 degrees. I'm going to show this calculation on both calculators just because I want to make sure you know how to do it. I might go back and do 7 too. So let's look at 7 just so that you can see it using the calculators that work backwards, because I know some of you have these, and then also if you're using your phone. So remember that I have to do the 75 first. So for this, I can still go left to right, but anytime that I have tangent, I have to do them in backwards order. So that would mean that I did 18 times, and then instead of doing tan, I'm doing 75 and then hitting tangent. And that still gives me 67.2. So I have to hit that equal sign at the end. That value that I saw before was just tangent of 75. So what's going to change for this one is that I'm dividing instead of multiplying. So I'm going to type in 49 divided by, and then 39 tangent. And again, that number is just tangent of 39, so I have to hit equals, and that's going to give me 60.5. And then just to double check it in the other calculator, if we're doing 49 divided by tangent of 39, notice it also gives me that 60.5. Okay, so just depending on what kind of calculator you're working with. Okay, so number 9 is actually going to be very similar to numbers 7 and 8, except that it's a word problem. So we have to kind of use the diagram to figure out what we're doing. So a plane takes off and climbs at a 12-degree angle. Is the angle sufficient enough to fly over a 11,088-foot mountain that is 2.5 miles from the runway, or does the plane need to increase its angle of ascent? So it's asking, if I solve for x, is x bigger than this height of the mountain or not, right? So will they need to increase their angle so that they can clear the mountain or not? One thing that you should notice is that this piece is in miles and this piece is in feet. And so what we want to do is to take the mountain and convert it to miles, because the miles are what's in the picture. So if I take this value, so if I have 11,088 feet, what I need to do is use a unit conversion to determine how many miles this is equivalent to. So I'm thinking about how many feet are in a mile, and that's 5,280. So since there are 5,280 feet in a mile, that means that if I divide 11,088 by 5,280, that'll tell me how many miles the mountain is. And so that gives me that the mountain is 2.1 miles. So what I'm going to do is I need to see, is x bigger than 2.1 or is it smaller? Okay, and that will allow me to answer the question. So if I'm looking at the triangle that they had drawn for us, we're identifying the hypotenuse. So the hypotenuse is the path of the plane. Since the angle is that 12 degrees over here on the left, that means that the side opposite is the x, and the side adjacent is 12.5 miles. So if we use tangent equals opposite over adjacent, that's going to give us that tangent of 12 degrees is equal to x over 12.5. And so now this problem looks just like what we did in problem 7, right? We had tangent of 75 equals x over a number. We cross multiplied and then calculated. So that's all that we're going to have to do here. So if I put tangent of 12 degrees over 1, and I want to get x first, so that means I'm going to do this diagonal. So that gives me that x is equal to 12.5 times tangent of 12. So if I calculate that, 12.5 times tangent of 12, that gives me about 2.7. Okay, so if I calculate that, that rounds up to about 2.7. So that means that x is about 2.7 miles. So if the mountain is 2.1 miles tall and the plane is going to get up to 2.7 miles when it reaches that 12.5 miles away, does it need to increase its angle of ascent or not? So it's getting higher than the mountain. So the angle is sufficient. Okay, so that is solving for sides. So we did two regular problems where we just have a triangle and one where it was an application. This next piece is solving for angles in a right triangle. So if I know two of the sides, I can solve for an angle in a right triangle. So the way that I do this is that theta is going to be equal to this tan with the -1 power. This is what's called inverse tangent. So when you see that, you say inverse tangent. It's also arc tangent. You don't say tan -1, you say inverse tangent, or you say arc tangent. And then you use the same ratio, so it's still the OA. So you would use inverse tangent of the opposite side over the adjacent side. So I'm still setting up the triangle in the same way. I'm just using the inverse tangent instead of the regular tangent equation that we were using in the previous problems. So let's start with identifying our hypotenuse. So right angles here, so that means that the hypotenuse is this diagonal side on this triangle. Since theta is here, that means that 21 is the opposite side. And then that 25 is the adjacent side. So that means that if I want to find theta and I know what the opposite and adjacent sides are, I'm going to take the inverse tangent of the ratio of the opposite side, which in this one was 21, over the adjacent side, which in this one was 25. So this is, again, strictly calculator. So we're going to look at, let's do Desmos first. So I want to type in what I have, inverse tangent of 21 over 25. So notice I don't have inverse tangent readily. Where it is under functions. So I'm going to do inverse tangent. And then if I click, how do I get back? No. Main, there we go. And then I do inverse tangent of 21. Oops. Of 21 divided by 25. That gives me 40.03. So that 3 is going to leave that as a 0. So that means that's going to give us that theta is 40.0 degrees. Okay, so let's look at that on a different type of calculator. So remember that when you're using one of these calculators, like your iPhone or one where you don't see what you type, you need to work backwards or inside out. So inside the trig function is the 21 over 25. So we're going to divide that first. So 21 divided by 25. And I'm going to press equal, see what that value is. And then under trigonometry, I'm going to hit second. So on a calculator, it's usually going to have a second button is how you get the inverse functions. They should be written right on top of the buttons with the originals. And this was inverse tangent. So that's 40.03, just like we had for the other one, to give us a 40-degree angle. Okay, so let's try that one more time before we're done. So I want to label the hypotenuse, which is across from the right angle. Then I want to take the angle that's labeled and identify the side opposite that, so that the other side is the side adjacent. So 10 is adjacent, 6 is opposite. So if I want to solve for theta, I'm going to say that theta degrees is equal to the inverse tangent of the ratio of O over A. So the ratio of 6 over 10. I'm just going to type this one into Desmos. So if I do our inverse tangent of 6 divided by 10, that gives me 30.96. So that 6 is going to round that 9 up. So this is actually going to be 31.0 degrees. So theta is about 31.0 degrees. Okay, so that's the tangent function. So opposite over adjacent on the sides in the right triangle are going to give us tangent. You need to make sure that you understand how to label the right triangle, because that's going to be crucial in the next lesson when we learn the other two trig functions. So what the SOH is and what the CAH is. Those are still always related to, we have to be able to label the right triangle like we did on this first page.